This is another problem on an ideal op-amp circuit, and our intention is to find out the value of the output of this circuit, which is referred to as V0. So the approach remains the same. What we have to do is to note that the voltage at the non-inverting input terminal is 0 volt because this is connected to the circuit ground, and therefore the voltage at the inverting input terminal, this node, should also be 0 volt from the concept of virtual short. Next, what we can do is we can take this as a node and then apply KCL, and we can easily note that if this is the current I1 that flows from this 2-volt source, if this current is I1, then because the op-amp is an ideal one, therefore no current can enter the input terminal of the op-amp, and therefore the entire current I1 should flow through this 2 kilo ohm resistance also. Now, notationally, if we call this as the current I2, then the relation between I1 and I2 is equal. So I1 is equal to I2, and therefore we can frame it in terms of the voltage divided by resistance expression as I1 can be represented as 2 volt minus of 0 volt divided by 2 kilo ohm, and I2 can be represented as 0 volt minus of voltage at this node. So we can call this voltage as Vp, and therefore the current I2 becomes 0 minus of Vp divided by 2 kilo ohms. So if we go ahead with solving this expression, we find out the value of Vp as negative 2 volts. Okay, next, if we target this node and apply KVL to it, apply KCL to it, we find that, let's say here is one incoming current I2, and then let us assume that another current flows from this node, and we call this current as I3. So this is current I3 also flowing into this node, and then the resultant current, that means the sum of these two currents, is going to flow to the ground via this resistance of 2 kilo ohms, and therefore if we call that current as I4, so I4 should be equal to I2 plus I3. This is again a relation from KCL, and as before, if we go ahead with framing the expressions for I2, I3 and I4 in terms of voltage and resistance relationship, so we can write I2 as 0 minus of Vp divided by 2 kilo ohms. I3 can be written as V0 minus of Vp by 2 kilo ohms, and finally this current can be written as Vp minus of 0 divided by 2 kilo ohms. Now note that I2 is the same as this current, and this current is the same as 2 minus 0 by 2 kilo ohms. So the current that flows up until this portion is 1 milliampere, and then here is a current which we are calling as I4, and since this voltage came out to be negative 2 volts, therefore the current should go up, and this will be equal to 2 divided by 2 kilo ohms, which is equal to 1 milliampere. So basically 2 milliampere of current is going to flow in this direction, and it will enter the op-amp through its output terminals. Anyways, let us return back to the expression that we had derived, and so from this expression we can find out that V0 turns out to be 3 times Vp, where Vp is equal to negative 2 volt, and so V0 is equal to 3 times negative 2 volts, which is equal to negative 6 volts.